Question number 4 says, a force F1 of magnitude 6.6 units acts on an object at the origin in a direction of theta equals 26 degrees above the positive x-axis. A second force of magnitude 5 acts on the object in the direction of the positive y-axis. Find graphically the magnitude and direction of the resultant force F1 plus F2. Alright, so we know that the first force, the first force mentioned is pulling this at 26 degrees, and the second force is pulling it straight up. And the first force has a magnitude of 6.6. The second one has a magnitude of 5. So we're trying to figure out what this is, and not only what it is, but what the magnitude is. So here's how we do it. We first figure out this distance, and the way we do that is by making our right triangle, and we know that 6.6 and 26 degrees. So this is our opposite, this is our adjacent, our y and our x. We'll call that x1 and y1. So our opposite over hypotenuse is the definition of sine theta. So the sine of 26 degrees equals our opposite over 6.6. So you work that out. Sine of 26 degrees, it is approximately like 0.43. Anyhow, you work this out and you can figure out that the opposite equals 2.89. So my y1 equals 2.89. Then I can do cosine, because cosine of theta, which in this case is 6.6, I'm sorry, in this case is 26 degrees. Cosine theta equals adjacent over hypotenuse, so a over 6.6. And you work that out algebraically, and you can find that your adjacent equals roughly 5.932. So x1 equals 5.932. So what about x2? So what we got so far, we got here, and we want to find out if this is my new x-axis, this is my new y-axis. I want to find out this is 5.0. Well, my change in x, since it's completely vertical, is going to be 5. My change in y is going to be, my change in x is going to be 0. And my change in y is going to be 5. It's fairly simple. So I now have my x2 and my y2, 0 and 5. So now I can add it up. x2 plus x1 equals 5.932 plus 0, y2 plus y1 equals 2.89 plus 5 equals 7.89. So what does that tell me? 5.932. That tells me that my x value, 5.932, my y value, 7.89. So I go over 1, 2, 3, 4, 5, 6, 5.92, 1, 2, 3, 4, 5, 6, 7, 8, 7.89, and I trace these guys out, and I know that that's my resultant vector. Now I can use a right triangle to solve the distance. Here we have on this line is 7.89 units long, and this one is 5.932 units long. So if a squared plus b squared equals c squared, then the square root of a squared plus b squared equals c. So we can use that, the square root of 5.932 squared plus 7.89 squared equals my distance. And what that ends up being, whenever you square everything, you end up getting like the square root of 62.3 plus 35.19. All of that equals 9.87. So D equals 9.87, and so you got, what you know now is that you have this line that's 9.87. You have this x value that's 5.932, and this y value that is 7.89. Now we can use our sign. We can use sine or cosine. We know that sine theta, which theta is unknown, equals opposite over hypotenuse. 7.8, this is odd, 7.89 over 9.87. I don't know how that worked out, but it just did. So sine theta equals, it equals 0.7997. So in order to solve for theta, theta equals the inverse sine times 0.7997 equals 53.103. So theta, our angle, is 53.1. So we have an angle of 53.1 degrees counterclockwise from our x-axis, and it has a magnitude of force of 9.87 newtons.